I'm going to start with a very simple question first. This is on the time-space diagram. So there is a relay race between two teams, each consisting of two athletes. In team A, the speed of the first athlete is 20 kilometers per hour, and the second is 30. Right? So there are two people, and there is a relay race. So in team B, two identical twins always run at the same speed. So in team B, both of them are running at the same speed. What must be the speed of the runner for team B so that the two teams finish at exactly the same time? So it is, I want you to solve it with respect to the time-space diagram point of view. Just to give you a hint, like there is like this, a team A and team B, they to run. So first one is running at 20, and when it reaches the back, the second guy was at 30. Here both of them are runs at speed V. What should be the speed V so that both this team finish at the same time? Sorry? 24. So 20 plus 30. Okay, yeah. You are taking the harmonic mean? Yeah. So the concept is pretty much like I wanted to introduce the concept of the harmonic mean or space-time here. First one is running at 20, second is running at 30, and the other speed is V. So if both of them should finish at the same time, it should be the slope of this line. Yeah. Which is the total distance traveled over the total time taken, which turns out to be the harmonic mean. I mean, if I have not introduced the concept of the space mean speed, the average is 20 plus 30 is 25. You would have thought about 25 should be the average speed, but actually because they are running for the same space, the radius is same. It is the harmonic mean you have to consider. So it is like think like this. First one runs for 20. Whatever distance this guy has covered, the second one has these distances are fixed. You get the time T1, you get the time T2. Total distance is 2D, and the total time is d over t v1 d over v2, which is the harmonic mean you get, right? So now I hope you understand the importance of the space mean speed. Now the next question is a bit tough question. Sorry, Nidwati, I started because you are late, right? So let them solve this question. This question is three friends take a long trip using a tandem bicycle for two people. So there are three guys, let's say A, B, and C. The bike riders can travel at a speed of 20 kilometers per hour. It is independent of the number of riders, and all the three persons can walk at a speed of 4 kilometers per hour. That's the speed which is given to us. Now the process they are following is like this. To start the journey, friend A and B ride the bicycle, and friend C walks. So basically, he rides the bicycle A and B and the speed of 20, and C is walking. After a while, friend A drops off friend B, who starts walking, and then A rides the bicycle alone in the reverse direction. So he might have gone then he drops B and A rides back, meets C, and then C and A rides again, and the chain keeps on moving. When A and C meet, they turn the bicycle around and ride forward until they catch up B. So at that moment, the three friends have completed one basic cycle of their strategy, which they then repeat a number of times until they reach their destination. The question here is, what is the average speed? Now you won't be able to solve it straight away, but I would like you to draw the time-space diagram and just get the concept first. You know the answer already. Perfect. Sorry? Okay, sorry, that's good then. So think of drawing the space-time diagram first about the whole process. So think like this. You have space-time diagram. A and B might be riding at speed of 20. So this time all three friends start the journey. A and B is going for 20, C is going for 4. That's why the slope of this line is 4, right? But after a while, imagine maybe after, let's say, half an hour or 1 hour, right? Let's check after 1 hour. Maybe at this point, A is going to drop C. Interesting thing is A is going to move back. So the time space diagram, the time is always moving in the positive from left to right. Space, because he's riding back. Now what's going to happen? The B starts walking. So B starts walking now. So this slope is same as that slope. Yeah. And then when A reaches B in future time or this time, both starts riding and then meet that at that location. So the question is at what speed these whole three friends are moving forward. So now again you will have something like this happening and you keep on moving. Now this question is just for you to understand the time space diagram. Now it's just a mathematical problem to solve, which I'm quite sure you will be able to solve that. So your average speed should be the slope of this line. But that's the speed in which they are actually moving. Sorry? I don't know the answer, frankly. I don't know what the answer is. Answer is 10? Okay. So how have you solved 10? Did you use a geometry or you use something else? Analytically? Okay. So how have you calculated the total distance? Okay. Mm-hmm. Good. Yeah.
That was very like it took too much of.
No, but how have you considered, like if you go to T1 and T2, what property of the parallelogram have you used? Well, you will only have one equation, right?
Yes.
You need a second equation if you think of two parameters.
I took total distance as 20 T1 plus 4 T2 plus 4 T3. I separated it into 3 timestamps.
Yeah.
And the total time will be T1 plus T2 plus T3. Then I needed some combination between T1 T2. So 20 T1 in that time it is 4 T1 plus T2 plus 20 T2. Then same this is relation between T1 and T2. Then 20 T3 is same as 20 T2 plus 4 T2 plus T3.
That's good.
So I got a relation between T1, T2, T3.
You can assume whatever parameter you want to assume as T1, T2, and T3. Ultimately, you have to find the relationship between T1, T2, and T3, or let's say this one moved for, let's say, 1 hour. So this is one, but then you have to estimate the other ones, and ultimately you have to find the relationship between those parameters. For that, you have to look at these as a parallelogram. These two lines are parallel to each other. This line is parallel to each other, and apply some of the geometry to actually solve it. Yeah. I think I have a solution here. Is like this. This is 20. This is 4. That's actually the gradient, as you see here, is what you're interested in. So AB is parallel to DC, and obviously this is a parallelogram. These two lines are actually parallel. So if you assume this as 1, which you have assumed T1, it becomes 20 times T1. If you assume this as, because if this is 1, this one should also be 1 because of the parallelogram property. But they are, because these are parallelograms, so this AE should be same as GJ. And from there, you can find, okay, this is 1, then this height will be 20 times 1, because this is 20. And you just keep on then solving it. And you say, okay, this is capital T. You assume this is capital T, and now you only have one parameter to solve. And you just apply your geometry on it. And what ultimately you are actually going to get is total distance is 24 plus 4T. Total time is just 3 plus 2. And when you do the calculation, 3 cancels out, and what you get is just 10 kilometers per hour. Now, I didn't go into too much detail because I know you guys should be very strong in maths. You will figure that out. My objective here is not for you to do that mathematical or simple geometric calculations. Objective was for you to think how the space-time diagram looks like and how you can apply it to actually do some kind of estimations. Yeah. I don't remember from where I borrowed this question. This solution I prepared when long time, 2011, when I was teaching at QUT. I gave that question, and I think I must have borrowed it from one of the Berkeley notes or some other notes. So
I
this is
think
not my question.
it is from Carlos Doganzo's
Oh, good,
book,
perfect.
Traffic Flow and Simulation.
Nice. So I might have used that question, and I've used that question since then in all my lectures for when I would talk about space-time diagram. And at that time when I was teaching them, it was hard for them to solve, and that's why I prepared the slide. I told you I had the slide, and I've used it for last 8-9 years, the same slide. Okay, that's for this one. My next question was on loop, but I have not taught the loops yet. So maybe you can start your question. Well, yeah. Are you guys comfortable with these two questions? Yeah. Yeah. Thank you.
Yeah, so here vehicles are observed in 5-minute intervals. So we are counting the number of vehicles that is passing through. And the total duration of their presence in the detection zone, that is in seconds, are recorded for 8 different classes of vehicle. So as we discussed, like India, we have multiple classes of vehicles. So here the different classes are mentioned here. You can see the small car, big car. So what usually you may ask, what is the difference between a small car and big car? Okay. So what is the difference between a small car and big car, you may ask? So it usually done based on cc. So it's more than 1500 cc, then usually considered as a big car. So we are doing the different classes of vehicle here. We are observing two-wheelers, truck, bus, then cycles are also there, that non-motorized cycles, three-wheelers, LCV, and tractor trailer. Okay, and what these are basically the horizontal projected area. So for each of this category, we are actually have a standardized length we can assume, although the length will not be like exactly same from vehicle to vehicle, but we can assume that there will be a negligible difference between them. So we can, based on that, we can estimate the projected area. Okay. Now, for this particular problem, so we recorded the values for every interval of 5 minutes. Okay. So you can see 0 to 5 minutes, we are observing some small cars, small big cars, small cars, big cars, LCV, like that we have observed. So what this 172.92 is, this is, let's say there are 20 number of cars you have observed. So the occupancy time, that the time we discussed in our earlier lecture, that T1 plus T2 or T2 plus T3, that time, cumulative time of those small cars are 172.92 seconds. So it is in seconds, as I mentioned. So similarly, big cars we recorded, whatever the observation we done, based on that we have recorded this one. So now if we have to estimate the area density, area occupancy based on this, so our detection area will be the 65 meter is the detection zone. So what will be the width we can say? So it's a 4-lane divided road. So we can say maybe around 7 meter we can assume. So 7 meter is the width of the road we can estimate, that we can think of, and 65 meter is the length. So that will be the area. So observation time is T here is 5 minutes. So in terms of second, 300 second we can observe. So if we try to solve this, this one, so this one is the projected area of each car, because when we need to estimate the occupancy, along with the time that is spent by each vehicle in that detection zone, we also need the area of individual vehicles, right? So area of individual types of vehicle is also incorporated here. Okay, shall we move ahead? Okay. Now, if we estimate the occupancy, okay. So this is done for first 5 minutes, okay. So the row as you can see, this row is done for the first 5 minutes. So here what we have done, the time occupied by each classes are there along with the area of the vehicles are also given here. So area occupancy if we consider estimate, so it will be basically the multiplication of this time with the individual area that we can do. So that will be on the numerator part, and denominator what we will have? We will have the area of the segment, right? 65 meter long segment is there. So 65 multiplied by 14, that is the width of the road, entire width of the road. That will be the area, and the capital T, that will be the 5 minutes into 60. We are, if you are converting into seconds. So by that measure we can estimate the area occupancy here. So same process we can do for other five. So we can record the data for each 5 minutes, and we can estimate the area occupancy like this in the similar fashion. Okay. So I think that will be my example from area occupancy, sir. This one? Yeah. Maximum altogether you are saying? Mm-hmm. So that is occupancy will be, if you are wanted to study, it's the surrogate of density, right? So density, if you, as you are witnessing over the different period of time, it will change over the day, right? So similarly, if you can look into the occupancy also in similar fashion, same thing you can observe, right? Like flows, as like flow speed, space mean speed, as sir mentioned, is changing over the time, right? So similarly fashion, if you are estimating area occupancy, that you can see how in 5 minutes, depending upon your observation. If you are doing here for, if your data need for 5-minute aggregation, you can do it for 5-minute aggregation. If it is needed for 15-minute aggregation, you can do for 15-minute aggregation also. So depending upon your objective, what you are going to look into it, you can aggregate and basically find. So if this aggregation, let's say here it is for 5 minutes. If you wanted to do that for 15 minutes, you can basically sum this for 3 columns together. You will get the occupancy for 15-minute data. Or if you are not in much finer level, like for 1 minute, that also you get. So depending upon your objective, you can basically find the occupancy whether you want it for 1 minute, 5 minutes or 15 minutes. That depends upon your research question. Mm-hmm.
For example, this one shows that trucks have the smallest area occupancy, right?
Trucks have the, will have the largest one.
Okay, that is the tractor area. The truck is having
17. Yeah. Yeah, yeah. So area, that is representing the area there.
In terms of density, should we say that more the trucks, obviously more the density?
More the density. So area occupancy also actually synonymous to density. As you said, you know, if area occupancy values are getting higher, that means much number of vehicles are occupying that particular space. Okay. Yeah, units will be different. It will be unitless, right? Because here. Mm-hmm. So you can develop plot for occupancy related plots also. You can develop instead of density. You can use occupancy related plots also.
In density, one of the problem is that like you need to define it to PCU, and PCU is a big issue. Like with PCU to adopt, and there are too many theories. So this is one approach where PCU concept is not required. So what
Yeah.
we are seeing that if you see from the top, wherever area you are not able to see the vehicle, that is basically occupied by the vehicle. You are not able to see the road, that got occupied by the vehicle. So if you keep taking pictures from the top, wherever vehicles are there, so you can define the density level based on that area which are occupied by the vehicle versus not occupied by the vehicle. So now density is defined by this parameter where you are like neglecting basically the PCU concept or maybe avoiding the PCU concept, not neglecting. So in this PCU concept, like so a particular vehicle get represented by its area, not by like its PCU value. So that's why
Yeah,
vehicle which
exactly.
are having higher area, they will obviously occupy more and they will create more congestion. So that way they try to attempt from a different perception that how this PCU, like instead of being in debate of PCU with PCU as is better, this is another approach to represent the density because higher area occupancy means like more area is got occupied by the vehicle, which is similar representation to the density, but we are not in it is not in vehicle. So all the fundamental relationship, if you draw with occupancy also, you will get similar kind of relationship, but values will be obviously different. This occupancy is in percentage, density you have certain different units. So this is like a different, altogether different thought process of like getting a other measure of density. So it's not a replacement, but like maybe still you can say this is equally a good measure to whether a particular condition is dense or like that.
Sir, like it might be a representation of the same, like we are considering a two lane, right? But actually, sometimes more vehicles come in that zone. So rather than two.
Lane is not a bar
No,
here.
sir,
Lane you
no.
can have 2 lane, 4 lane.
Hmm.
So you can have entire area.
So, sir, my question is like this is giving us two pictures. Even if it is a two lane, and if suppose two wheelers in case comes within, so it is violating, but it is giving a two picture.
Yeah.
So one thing, when we are considering this area, is it only taking the length and width of the vehicle or the clear spacing between the vehicles?
Length and width of it.
Length and width of the vehicle.
Actual dimension of the vehicle. All this, whatever he is representing, this is like actual area of the surface area of the top of the vehicle.
Suppose if we want to consider the paved shoulder also, then we can extend that area, we can consider here, then we can get.
If you consider paved shoulder, that is equally like considered for active mobility, like all the vehicles should be able to move over it, part of the carriageway, then you can consider that entire area. Or if you don't part of like the majority of time we don't consider by completing capacity. So that way, like paved shoulder will be different because sometimes paved shoulder design is different. So their pavement crust level is designed differently. Although from the top surface will be same, but inside the crust level will be different. So if that concern is there, then you cannot expect that truck will be moving on the pavement. But obviously light vehicle can move.
But in reality, not the marking will be there.
Yeah,
Marking
marking will be
after
there.
that, on that asphalt layer also, two wheelers used to
Yes.
move in.
So this is additional. Earlier, like we used to have like the other paved shoulder, but with the different material. But there are always issue with the pavement and concrete interface. So that is why like this concept came. Like let us continue that same surface. But most of the time we don't consider that is part of the like kind of capacity.
That means for 910 meters square, so 0.005539,
Mm-hmm.
55.39 percentage.
No, it's
No,
0.55.
no, it's
0.55.
it will be 0.55. So this is like now you can assume that very light traffics are there. Light, yeah. Traffic now flow is, you can assume that it is on the uncongested condition. So as it is, you can see the values are going up, but I think this data is taken from this one of the early morning time, I think, scenario, if I remember. So that's why traffic is still on low. So this occupancy will keep increasing as the traffic will increase.
Even if you consider like percentage, this the top value will be like 0.005, that becomes 0.5%. So you will not have 50% occupancy because like that you have to maintain the distance. So that way, some area will be definitely remain by. So occupancy will never be 100%. It might be only maybe maximum might be 10%, 12%. So that becomes like corresponding to optimal density kind of thing. That is optimal case. So we can say 10% will be the critical occupancy. Might be. That exact value, I don't recall that how much is the area occupancy in terms of like optimal density. That may be like if you run through the data, you will be able to figure it out. But it will definitely not be 50%. It will be much
lesser than that. Yeah.
So just one fundamental question I'm just trying to understand. If at a given moment I'm able to calculate this, let's say over several factors of length, per kilometer width, 200 meters. So that information that we have now on the occupancy can be used for controlling something. Because ultimately, one is information is going to give us.
Yes, interventions you can do. Interventions definitely you can think of.
So this is particularly for mid-block section.
Mid-block section, no, only you can for any this one you can.
So if you don't want to bring PTO thing into it, like this can be used then the other case is always per lane. So for Indian conditions, people work it like entire week because per lane business is not there. Lane business is not there. So once you set per entire week, then the density definition itself becomes a little bit dicey. So that is why like people have started working once you are considering the entire week, then better to have area instead of like having number.
So this is calculated from an ROB, road overbridge. So elevated you can calculate from the any high-rise structure you can.
If you are standing on the side, so you can count that how many number of different type of vehicles went, and the standard dimension is known. You can figure it out.
Because there are specific areas that are 500 feet and all that. It was a proper image that was then extracted.
Yeah. So this data is like after like a car might be wide variety. So they might have samples few cars, then they figure out that this might be the main car. And this has been like taken from the published paper. So you can do it like your survey and figure it out what is the optimal value dimension for the car. Otherwise, you can take the type design vehicle dimension as a reference. Maybe we can others if you want to discuss like we will discuss some other.
I'm just trying to read questions from you guys. Maybe other questions was on loop vector, and I'm not discuss loop, so I have to switch you off.
Are you going to share this?
Yes, I can share this question. Yeah.
Don't worry, we are teachers.
We share everything. Don't worry. Like some of
nothing secret.
there's nothing secret. Some of them I'm just. Why is not showing there? Mine? I believe so. It looks like mine. Okay. Here you go. Yes, it's mine. Yeah. Okay. Now this question is: suppose I give you a travel time along a road section, right? So I've now given you the travel time value, and every 5 minutes the travel time is given to you from some source, maybe the here data set or some other data set. And you also know the volume in that 5 minutes. What is the space mean speed in this case? So what we have discussed in the class was the speed was given to you, but now I've given you the travel time. What's the space mean speed? Sorry? I don't know the answer. I will solve it now. Okay, so you have one answer, 63.5. Yeah. The travel time is in seconds. Number of vehicles are number of vehicles every 5 minutes. Yeah. So from 7 to 7:05, we have 90 is the average travel time for those 10 vehicles. 7:05 to 7:10 is 88 seconds basically for 20 vehicles, and 7:10 to 7:15 is 76. So please note the second column is travel time. It is not the speed. In the class example, I have given you speed and the volume, and I ask you what was the space mean speed. In this case, I have given you travel time. Any other answer? Apply the generic definition of speed is the total distance traveled over total time taken. That's what you have to apply here. You can assume any distance, say the distance is 1 unit of time, or sorry, 1 unit of space. The total distance will be similarly simple, the sum of what you're getting in the unit of space. Total time is already known to you, but keep the number of vehicles in mind. How much? What's the unit? 80. It's in kilometers per hour. Okay, let's solve it now. Suppose that the distance is, let's say d, or let's call it 1 kilometer for the sake of discussion. So the distance traveled by these 10 vehicles will be that distance 10 times whatever distance you specify, right? D. Second, 20 vehicles will be also 20 times d. Third will be, let's say, 30 times d, because that's the number of vehicles, right? If d was 1, this should be 50, right? 50 times d. Oh, sorry, 60, my bad. 60 times d. Total time should be what? 90 on average, right? Is an average. So what is the total time for those 10 vehicles? Should be 90 times 10, right? So the total time taken by these 10 vehicles will be 90 times 10. Second one will be 88 times 10. Third one will be 76 times 10. Right? My bad, I'm not looking at it properly because I can't see the screen, sorry. What happened? It will be simply 90 times 10. Second one will be 88 times 20. And third one will be 76 times 30. So total time taken will be summation of all these one that you get. Right? I have to give a distance, otherwise you cannot calculate this one. It has to be total distance traveled over total time taken should be your answer. So distance was not given, so the question was incomplete. I just prepared on the fly. So you have to have a distance. No, but this one D is not anywhere here. So it will be 4940 divided by 60 times D. So you need to have a distance value. Let's say the distance was 1 kilometer. Then your average speed should be total distance traveled divided by total time taken. That's the answer. Yeah. So are you fine with this? Now the answer is not important for me, the concept is important for me. What I wanted to say to you, the reason I framed this question, and you can see when you frame question on the fly, you can miss something. And I didn't solve it, I just framed that way. But I thought if I give you the speed value, if I give you that, you can simply apply the harmonic mean equation, the one that we discussed. But I want you to think beyond harmonic mean. I want you to think that, look, average speed is the total distance traveled over total time taken, and you calculate that average speed accordingly.
So this maybe you can attempt here travel time is given. So instead of speed, travel time is given, you figure out average travel time.
Yeah.
So here, because numbers are different, so you take weighted mean of average travel time and inverse it, you will get the speed.
Got it? I have actually one more. I think one more question. I will just. Do you have time? No.
Then they have to
Yeah.
send the last one.
That's fine.
So you need to talk about data.
No, this is last. It's 5:30, right? I will talk about it tomorrow then. Because if I start talking about Bluetooth, it will take long. So I will just. Are you fine with this, right? Okay. This is the question I want you to draw. So it is for the fundamental diagram, and assume that triangular shape for the fundamental diagram. So fundamental diagram can have any shape, assume it has a triangular shape. Think of whatever triangle you want to think of. Here, let's say on the motorway section, it's a motorway, it's a 2-lane motorway. The capacity is given to you as 3600 vehicles per hour. So please check the unit, 3600 vehicles per hour. Jam density is given to you as 180 vehicles per kilometer per lane. Free flow speed is 90 kilometers per hour. So assume a triangular approximation of the flow density diagram. Can you sketch the diagram first and actually point all the values there? And after that, I want you to estimate the average running speed of the motorway when the density is 40 vehicles per kilometer per lane. I'm not going to solve it because I do not know the solution, but I'm going to draw how we can do it. Is it possible to write it on this board now? No, it's showing somehow it was.
Connected with the desktop, then you can.
Oh, okay. So here I will try to. I will duplicate the screens. I think it will be better. Yeah, maybe that way it is better. Yes. So please give it a go. They have to assume a triangular shape. That's the only thing there. Yeah, yeah. Triangular, either symmetric or whatever they form. So it should. Yeah, but I've given the capacity and the free flow speed. So capacity and free flow speed is given to you. So from the free flow speed and the capacity, you can find where the free flow speed hits the capacity. So let me. So what you have to draw here is a fundamental diagram between, let's say, flow and density. Let's call Q here and density there. And what is given to you is the capacity of the road, the maximum flow that actually it can reach. That is actually given to you. You know the capacity value. But please note the capacity has a unit. What is given to you is a free flow speed. And remember the fundamental diagram, the slope of the line at this point is the free flow speed. So the free flow speed is given to you. Capacity is given to you, so you know that point where it should hit if you want to make a triangular shape. And the jam density is given to you, so you can draw the triangle accordingly. Remember the slope of the line, slope of the fundamental diagram when the density and the flow is 0 at that point is the free flow speed. So the slope of this line is the free flow speed. This is given to you. Capacity is given to you. It has to be the maximum has to go there. So this line maximum will go somewhere there, right? But now you need to figure out how the shape looks like. Thanks, Rakesh, for asking. I thought I might have also missed information this time. Yeah. Then jam density is given to you. So there should be some other point in your space-time diagram, and then you try to join the dots. Assume there is no capacity drop because I'm talking about a triangular shape. There is no capacity drop in this case. If I would have set the capacity drop, the shape will change. Then it's a discontinuous fundamental diagram. So if the jam density is known to you, it should be somewhere here, right? So the maximum density, the jam density, let's say this is the maximum density, this is the jam density, then this is the shape of the fundamental diagram that directly you will get. Now obviously it will not be symmetric, actually it should be, because based on the values it should be something like this. So that should be the jam density value. This is the jam density. That's the capacity. So that's a triangular shape. But if I would have said to you that there is a drop in the capacity by 20%, sketch that, then you would have to drop this point by 20% and then draw this line like this, or whatever form it is, right? I mean, the point is whatever shape you draw, talk about the assumption. So in this case, the assumption is there is no capacity drop, and let's work with that assumption. But that is going to complicate more. I have not talked about the more complex ways of representing fundamental diagram, especially when you have that capacity drop and other phenomena in terms of hysteresis, etc. Let's make it simple. So now from here, jam density is known to you, which is 180 vehicles per kilometer per lane. Capacity is known to you, 3600 vehicles per hour. Free flow speed is known to you, which is 90 kilometers per hour. You can figure out these dot points, but please check the units. Units are very important. If you do not check the units, you are going to make some errors in your calculation. So the unit for jam density is 180 vehicles per kilometer per lane. So this is 180. Capacity is 3600 vehicles per hour. Number of lanes is 2. Try to make both of them per unit per lane. Otherwise, you will not be able to solve it properly. Because to get this point of density, given the speed of 100, both of them should be either per lane or they should not be per lane. So if I say 3600, so this will be 3600 vehicles per hour. This will be around 1800 vehicles per hour per lane, right? Jam density is given to you as 180 vehicles per kilometer per lane. The slope of this line is 100 kilometers per hour. So from here, you can figure out the critical density. Sorry, oh, 90, sorry, you're right. 90. Slope is 90. So what is the value of the critical density? What's the value of the critical density? 20 vehicles per kilometer per lane. Do not miss per lane there. This is 20, right? Vehicles per kilometer per lane, right? What is the expected average running speed when the motorway density is 40? So the density was 40 here, let's say twice of this, maybe that's 40. What is the average running speed at that time? So you want to know the speed when the density was 40.
39.375.
Okay, I have not solved the question myself. That's good. So you might have tried to find this point here, and slope of this line is the speed, right? And because you know the coordinates here, you can easily find what should be the coordinate here, or how long should be the flow value when it was 40. Yeah, and then you can find the slope.
We can also do similar triangles, no? For 20,
Yeah,
40.
that's geometry you can do. Yeah,
Q is equals
he's a
to-
smart guy. That's good. Yeah, you can do the similar triangle also. So one of the common mistakes that we do in the calculation here is we mess up with the units. If you have used, let's say, 180 here, vehicles per kilometer per lane, and simply use 3600, all the calculations will be wrong. So never, ever, never, ever miss the units in any engineering calculations. 36 has no value for me. 36 plus what it is. Is it a vehicles per kilometer or whatever the unit behind is? I think in the very first lecture of engineering, when you are taught engineering statics, they talk about the significance, they talk about the units. And they said this is the foundation. Good. I think we are pretty much on time now.
Any other question?
Please ask the question that we have discussed today, and tomorrow we are going to continue with first with the lecture from Professor Akhilesh, and then I will talk about the Bluetooth. Yes.
So, any question? So, if no question, like how was the class today? Like whether you are able to understand some of the fundamentals or not? Yeah. So that journey will continue next 4 days. So tomorrow we'll be meeting at 9 a.m. sharp. So this better to join at 9 a.m. Otherwise, like once we start discussing and half of the work is done, then you may not able to follow the rest of the lecture. Okay, so 9 o'clock, like you come here. So we'll start, and we will talk about like various type of parameter measurement in Indian context. Like maybe like he will be discussing subsequently Bluetooth and those things. So how like for Indian traffic stream, how you can determine the parameter, what are the different methodology people can adopt. So we'll be discussing about sensor based data collection and maybe drone based data collection. Then how you can utilize that data collection this to modeling. That modeling we will be discussing in the last simulation. But data, how we collect those required parameter of data, that will be discussed tomorrow. Okay, then enjoy, like roam around the campus, at least see there, like people who are from outside, so can enjoy the natural beauty here. And during this towards the end of this, like even you will have the IIT Guwahati's cultural fest. Alchiranga will start on Friday. So maybe one day you can enjoy that as well after the class, not before the class. Okay, thank you. Yeah.